This is a bit of an involved question, but I would like to claim that it is quite a bit easier to do on your own than it is for me to do in a video, because the reason that it's so tough, for me at least, is cramming the whole diagram onto the screen. If you have more space for the diagram and you can look at all the code at once, maybe the question gets a bit easier, but it's still a bit involved. So we have some structure definitions, there they are there, and they are the same structure definitions, in fact, that were used in that question about the types of expressions. And then there's the function main and two other functions, but I couldn't fit them all on the same page, and so we're going to have to skip between them. I guess that also means the line numbers are sort of meaningless. That means I'm going to have to pick my diagram up between pages and move it around, so that's going to be fun too. So just to try and make my life a little bit easier, I have pre-drawn some of the diagram for main. So we've seen, the stopping condition is there is this variable pair A in main. It has a member Y, so there it is. Let's color that in, because the prompt says stop as soon as this variable gets a value other than 10. But we first have to give it its initial value. But this will be my stopping condition when this variable gets modified. Okay, so line 12, I set x and y to be 6 and 10. On line 13, in this other variable, pair B, I set the elements to be 17 and 187. And so I'm going to be throwing this structure and pointers to it around the program, and I want to watch for whenever this gets changed to any value but 10. So it could get assigned, but if it's assigned to value 10, we keep going. It's only if it gets changed to something different. Okay, line 14, I create this line segment object. And notice that strangely, in the line segment object, I am not storing actual XY pairs. I'm storing pointers to them, which is a little bit weird, although it's still valid. So I make a line segment object on line 14. On line 15, I set the start point member to be pointing at pair A. I set the end point member to point at pair B. And then on line 18, I try to call a function f2. So the problem here is that I don't actually have f2 in front of me. I've got to sort of play this by ear. However, it looks as if f2 takes an argument of type line segment. So we'll scroll back and see if we believe that. Okay, yes, it takes a line segment object s. And I got to be very careful how I set this up. So it's taking a line segment object itself. It's not taking a pointer. It's taking an actual line segment, which means what it is receiving is a copy of what gets passed in from main. So I need a line segment structure to work with. I'll work with this one. So there it is. There's my line segment. And in F, it's actually called S. Okay, and so when I pass in from main the value seg, what I'm doing is I'm making a complete copy, member for member, of that structure. So the member's start point is a pointer at pair A in main. So in the copy, the same thing is true. The member end point is a pointer at pair B in main. So in the copy, the same thing is true. Notice that I make a member for member copy, but it doesn't mean that I copy the destination of those pointers. I just take each value and I transplant it into the new structure. And to be clear, by the miracle of scoping, the variable s in F2 is not the same as the variable seg in main. A copy was passed in. So if this gets modified, this thing in main does not. I think we now have enough to actually go run F2. So let's pick this diagram up and step over here where we've got F2. Okay, so there's F2. The first line of F2 creates an XY pair object. So I'm going to borrow this one. There, and put it there. I guess I got to clean it up a bit, so we'll hollow that out. And its name is just pair. All right, and so it's set to the values. Its initial value is x is -1 and y is -1. All right, and then, and actually I'm going to move this a little bit because it looks like we're going to have a problem if I don't. Okay. All right, and then on line number 13 on this page, s.endpoint equals s.startpoint. In the past, I've encouraged when you see these assignments have pointers on both sides, it's often better to cross out the thing on the right and write in what it really means. So what is s.startpoint? It's a pointer to pair A in main. So I'm going to write that in. Okay, pointer to pair A in main. S.endpoint gets a pointer to pair A in main. Okay, so that I can do. So my variable S is in F2 is this structure here. I set this dot endpoint to be a pointer to pair A. I guess we'll go up around there. Pair A in main. All right. Line number 14, S.startPoint equals arrow pointing at pair. Well, in the scope of F2, this is what pair means. It's this structure over here. So let's see. Arrow pointing, I'm going to erase the current value of S.startPoint. There we go. And then this will now point at pair. All right. And then line 15, we actually make a pointer here. So PT XY pair star. And we're going to set that to be the result of another function that we also haven't seen yet. So I'm going to set up the box for that. I'll do it here. And it appears as if what it takes as its argument is of type, let's see, well, S is a line segment. So it appears as if F1 is taking an argument of type line segment star. And if we go look at F1, yep, that is what it's doing. Seg pointer. All right, and so I want to get far enough into this that I have the argument set up before I change pages. So ampersand S here would be arrow pointing at my variable S in F2. So I think F1 ends up with this. There it is. An arrow pointing at the entire line segment structure. Okay, I think we are now ready to pick this up and head over to that other page. All right, so here we are on the other page. That fits about as well as I could expect. All right, so we are ready to begin executing the function F1. The return type of F1 is XY pair star, and that's going to end up getting stored in this variable over here. So first line, seg pointer, arrow start point, arrow y equals 111. Okay, so with the arrow operator, I am just following pointers all the way through. So I seg pointer, follow an arrow, get me the member start point. Okay, that's this. Follow the arrow from that. That gets me to here. Set the member called y to be 111. All right. And then line 13, make another XY pair object. All right, so I'll borrow the one from main again. Put it there. Is that the last variable I'm going to need in this diagram? I think so. Okay, so I make an XY pair object called pair. And I'm setting it to be equal to this expression here. So if you follow the arrows here, so seg pointer, arrow start point. Okay, that's this pointer here. So if maybe I'll put brackets to make it clear which sub-expression I'm talking about. Seg pointer arrow start point would be this pointer. So what I'm saying on line 13 is set my variable pair to be equal to whatever you end up at if you follow the pointer, seg pointer arrow start point. So this pointer here. So star of this takes me to this structure. So set the variable pair in F1 to be an exact copy of this thing here. Okay, so x is -1, y is 111. We are allowed to use the single equal sign on structures, unlike on arrays. We're allowed to make a full copy of the structure when we need it. And that's what's happened on line 13. Okay, line 14. And I'm going to make an assumption here. I'm noticing that inside the if statement there are no declarations, and inside the else also no declarations. Therefore, I am not going to bother drawing a nested scoping box here for a lot of reasons, one of which is I don't have any space. But also, there's nothing that could happen inside a nested scope if I'm not declaring any variables. So I will just run the if statement without the nested scope. If pair.x is less than 0, okay, well, here's my variable pair. It.x would be -1. That is less than 0. Okay, so I go inside the if. All right, pair.y equals -1. Well, I'm in F1, so pair.y would be this thing here. I change it to -1. That looks good. Then seg pointer arrow endpoint arrow x equals 116. Okay, segment pointer arrow endpoint arrow, and then the member x, that equals 116. All right, return this thing, seg pointer arrow endpoint. Okay, so what am I returning? Seg pointer, follow the arrow, end is this thing. I'm returning the contents of this box, an arrow pointing at pair A in main. So I'm going to write it in. Pointer to pair A in main. That is what is being returned from my function f1. So a couple of things. One, I guess f1 is now over. And if we go look at f2, the return value from f1 is getting assigned to the variable pt. I guess I'll do that before I move the diagram. So it'll get an arrow pointing at pair A in main. So it gets this. All right, so now let's clean the diagram up a bit. Let's get rid of the scope for f1. There we go. We'll get rid of this arrow here. And we'll get rid of this. And then we will pick our diagram up and bring it back to the slide where I took it from. You might want to think to yourself, how many takes do you think Bill did of the video before he got to a point where he was willing to keep one? Will he even end up keeping this take? Okay, so we'll put this back over here. And actually, I think I forgot to get rid of it in this end. There we go. Okay, so now we are back on line 15, and we are done calling the function f1, and then I write here on line 16, I say pt arrow y equals pt arrow x minus 10. Well, obviously, I probably should try and do that right-hand side first. What is pt arrow x? Follow the arrow from pt, get the member x, that's the number 116. Okay, subtract 10 from that, that's going to give us the number 106, and then assign that value to pt arrow y. Okay, pt arrow y, follow the arrow from pt, there's y, there's the value 106. All right. And so I've just modified that member that we were watching, and so mercifully, the question can now end. It turns out there is other stuff main could have done, but I don't have to do it. So in this case, the prompt, if you take a look at the question in the online version, the prompt was give each of the following things: pair A.x, pair A.y, all of these in the scope of main, of course, pair B dot x and pair b dot y. In the scope of main, pair a dot x is 116, pair a dot y is 106, pair b dot x is 17, pair b dot y is 187. So, okay, yes, it's a bit of a nasty question. I don't think it's as nasty as it looks from the example because you don't have to keep picking up and juggling your diagrams like I do.